Morning, Liberty. How you doing this morning? Happy Friday. Weekend coming up. Looking forward to it. I don't know if you saw the news, Liberty, but it looks like May 15th, some stuff is starting to open up. I'm doing well. Thanks for asking. Doing good. Yeah, I saw that Mike DeWine came out and announced some stuff is on the 15th is opening up, which, part of me is excited about it. Part of me is also, tentative about it. I don't know. It just seems like statistically nothing has changed, so it's a little scary to think about okay, we've put all this time and effort and hard work into quarantining and be away from people, and we're doing all this these things people are telling us to, and now if we all just go back to normal, I don't know, it's a little scary. It's like, are we just gonna throw this all, is all this gonna be a waste of time? Do we just do this for no reason and then it's just gonna break out like crazy anyways? I don't know. Makes me a little hesitant. I still feel like we're so unclear of what's really going on, and with especially specifically with the virus. I don't feel like people really know what it is and what it can do. So I don't know. I agree, right, Liberty. It is a little premature, I think. So I'm gonna take it pretty casually. I mean, it'll be nice just to go out and feel less judged when you're out. But I haven't been out much. The only time I am is when I'm getting groceries and stuff. But still, I don't want people to be stupid. I do really need a haircut though, so I might need to go get one. I have a feeling everyone's gonna get a haircut though. So yeah, I don't know. It's a hard situation. I feel like people are excited, but also, like you said, people think it's a little premature. Oh well. Have you guys heard anything about graduation? Anything in terms of that? Do you guys have any updates on that? I had to go to the store to get parts to fix my car, and there were only a handful of people wearing masks. See, that's the stupidity I'm talking about, Liberty. I know a lot of places are forcing you to wear masks, but I don't know. To me, it seems like you're just. It's not about you, really. I mean, you're just putting other people at risk, regardless of how you feel. I get it. Some people are just and especially older people are in that mindset, I'm not gonna do what they make me do, blah blah blah. But I don't know. It's not that big of a deal, especially if you're just going out to a store. It's different if you're hanging out with your family and wearing a mask the whole time. It's a little bit different. But if you're just going out to pick up car parts or pick up groceries, I don't know. I don't really see a big issue with it. It's not that inconvenient. Plus, it gives people that sound state of safe mindset. So I think that's kind of important. Just wearing the mask that makes people feel more comfortable. Whenever I see people in public now without masks, like I said, public in a store standpoint, I'm kind of just really, I don't know. Liberty, so completely virtual. They hired a videographer to get us all walking the stage. They'll record speeches, performances, and whatever other parts. So what do you think about that, Liberty? Personally, what's your opinion on that situation? So walking the stage and they'll record speeches, performances, whatever. I mean, it's from my perspective, it seems like they're really doing a good job with what they have. I mean, it's not ideal, but it's kind of cool that they're at least going to do it virtually and let you walk, so to speak, and do the speeches and all that. And the one I've thought about it too, it's yes, it's not the traditional graduation. Yes, it's not ideal in any way. But it is unprecedented, and you guys will have this for the rest of your lives. It'll always be a story. You'll always be able to tell people hey, when I was in high school, that's what happened. Which it's not ideal, but I can't tell you anything interesting about my graduation. Nothing interesting happened. She said, I think if the administration were to go forward with an in-person graduation, that would be a huge liability if hundreds of people. Yeah, that's the thing, and it's like you know like from the bottom of all their hearts, that's all they want to do is they want to give you guys an in-person graduation and make everything as normal as possible. And if there was even a slight chance they could, they would do it. I think it's just not doable. It's too much of a liability because you have half the community is going to this graduation, and you like you said, if 2 people are sick, that thing is gonna spread like crazy. It'd be one thing if like we hadn't had any cases yet or something in Ohio, and like no one was sick or anything. That'd be a one thing, but people graduate, they have family from out of state. There's just so many things that can go wrong. So as much as it stinks, I kind of understand. I feel bad for how much they're all getting bashed on social media. Oh yeah, see, I haven't even seen any of that. I can imagine though. I'm assuming kids and parents and all that. I don't know. It's one thing, obviously, it's one thing being outside of the situation and another thing being inside. At the end of the day, the administrations and teachers and everyone who's helping out, everyone's goal is just to keep everyone safe. At the end of the day, that's all that matters. Everyone's healthy, safe. No one's contracting a deadly virus. That's all that anyone cares about. Obviously, everyone would love to have a beautiful graduation, have all this fun, and make everything perfect. But if it means that it's going to put people at risk, it's not worth it. And, people who don't understand that, you let them air their grievances and on social media and complain and all that and bash people, whatever. But I think everyone's doing what they can, so it's really sad, but it's the situation we're in. All right, so it looks like it's just you, Liberty. I know we went over 1 and 3. I don't know if we got through 4 and 5. I can't remember if we went over those. So we can start there and then do 6 as well. Whatever you want to do, you let me know. I feel like maybe we did go over 3 and 4, or 4 and 5, I mean. At least the answers for 5. I don't know if we finished it. All right, you said we did. All right, so yeah, if you remember for 5, I know 4 were good. For 5, if you wanted to, I can't remember if we finished it completely. I still have to do 6 guys. Yeah, go ahead, Liberty. Just do 6 now. A through C, Liberty for 6, no D. Hey, Liberty, by any chance, did you see that Google form I put to Google Classroom? I got a notification. It's up to you. You don't have to do it now. I just wanted to tell you because I just realized this morning. I didn't fill out a part where you can put your name, and I assigned this to Calc AB as well, but I don't want to get them confused with you guys because I know you guys are gonna have different needs than Calc AB will. So when you fill it out, or if you fill it out, do you mind putting your name somewhere? So just like at the end of your response, just put Liberty Oliver. So just so I know I can separate BC from AB. So like if you're asking for something specifically, you or Rachel, maybe the other 2 will join. Most likely you and Rachel will be the only ones there. So I want to gear it so it's helping you 2 out more so than like all of AB. Cool. Thank you. Is there a difference between first four non-zero terms and general? Yes, there is. So the difference is, Liberty, is the first four is the actually plugging in n equals 0, 1, 2, 3, so on. General terms, whenever it says a general term, you're going to do that. So you'll start off where you'll do, the first maybe three. I don't know if it says in the question if it specifies. I think it says the first four general term of Taylor series. Oh, and general term. Okay, so yeah, you'll do the first four like normal, and then the general term is just a way, it's a formula that you can find every single term after. So you plug in an n, so to find the fifth term, you plug in n equals 5, sixth term, plug in n equals 6, but you want a general formula that will allow you to solve that. So that's what that means. Yeah, it's gonna be a Taylor series, and then as long as you include the general form, so the general term, then yeah, I think the question. Let me look at the question again. I believe it just wanted you to do the first four like normal. Yeah, and then the general term will just be, yeah, the Taylor series, exactly, just without the series part. Do I have to do ratio tests for B on the Taylor series I created in A? So actually for B, you don't need to do a ratio test. And here's why. Because they actually tell you, they basically did it for you. They give you the information. They say that the radius of convergence is 2. And they say it's centered at 1. So if we want to find the interval of convergence, if we know it's centered at 1 and the radius is 2, it means it could be plus 2, so 3, or it could be minus 2, negative 1. So we can actually, without doing the ratio test, without doing all that work, we already know what the interval is going to be. We just have to determine at the endpoints, at the end of the intervals, is it going to be convergent or divergent? And then when you're doing that, yes, you would use the series that you got from part A. Yeah, I will, Liberty. All right. So, to give us a Taylor series centered about x equals 1, it is known that f of 1 equals 1, f prime of 1 equals negative 1 half, and the nth derivative of f is given by f to the nth derivative of 1 is equal to negative 1 to the n times n minus 1 factorial divided by 2 to the n. The first part, A, is write the first 4 non-zero terms and the general term of the Taylor series for f. Okay, so the first, so the whole thing, I guess, would be look something like this. You'll have 1 minus 1 half times x minus 1 plus 1/8 times x minus 1 squared minus 1 over 24 times x minus 1 cubed plus negative 1 to the n times n minus 1 factorial divided by 2 to the n times n factorial, and that whole fraction times x minus 1 to the nth power plus . So basically you're just, those dots are just filling in like, hey, somewhere here is, anywhere in between here is going to be this general term. B, like I said, your radius of convergence is negative 1 to 3, or your radius of convergence is 2. It's centered at 1, so your interval is going to be negative 1 to 3. So what you needed to do was test the series when n is negative 1 and when x is negative 1 and when x is 3. So when x is negative 1, you should have got the series was divergent. And when x was 3, you should have gotten that the series was convergent. Which means that your final answer for your interval of convergence would be negative 1 is less than x, which is less than or equal to 3. And then part C, it says the Taylor series for f about x equals 1 can be used to represent f of 1.2 as an alternating series. Use the first 3 non-zero terms. So you just want to use the first 3. So A, use the first 4. Just do the first 3 of those, meaning 1 half times x minus 1 and 1/8 times x minus 1 squared. So you're going to use just those first 3 terms, and then you're going to plug in 1.2 for x. So it's going to be 1 minus 1 half times 0.2 plus 1/8 times 0.2 squared. Put that in your calculator. It equals 0.905. And that's number 6. Anything you want me to go over, Liberty? You feel good about that? I know like the 6A was really hard for me to say voicing it, so if you want me to write it down, I can write it down just to double check. Okay, perfect. Okay. Yeah, if you're good then. Sounds good to me. So Liberty, this weekend, I posted to Google Classroom. It was a just my own like customized, I don't know, I guess study guide kind of thing. Not content wise, just my recommendations of what I think this weekend would be useful to do. I've said this before. I don't think cramming is going to be like the efficient method. I want you obviously to look over your material, specifically look over maybe what you struggle with. So in past assignments, what you haven't understood completely, or just types of problems you'd like to look at. Fill out that survey for me and let me know so Monday I can talk about it. Make sure you put your name on it. But yeah, I put out this Google Doc that's kind of telling you what I think you should make sure you have done this weekend so you're ready for next Tuesday. So take a look at that. It's not like an assignment, it's just my advice. So maybe you'll see something on there you think, oh, that's a good idea, or yeah, I should probably do that. So take a look at that. But you don't have any assignments over the weekend. Yeah. And then we'll tackle some last second stuff on Monday. And then Tuesday's the day. The day we've all been waiting for. This year's built up to. Yeah, no problem, Liberty. Have a great rest of your day. Enjoy the weekend. Happy Friday, Haber. Happy Friday indeed. Morning, Andrew. Happy Friday. Hope everyone's doing good. Morning, Alexis. Good morning, Jasmine. Love the exclamation points. Good excitement on this Friday. Kind of a chilly Friday, for being honest. If I check the temperature, I think it's like low 40s. What's that about? It's May. It's going to start snowing or something. Morning, Alexis. Yeah, 43 degrees right now. It's only going to get colder. That's ridiculous. But the end of next week, I don't know if you guys have seen, end of next week, whoo, supposed to get in the 60s. Now we're talking. A little bit rainy, but. Morning, Peyton. Anyone have anything cool going on this weekend? Any plans? All right. So guys, while I'm waiting for a couple more people, giving some people more time to stop in, we're gonna go over 2018 FRQ. So that's what we've been working on all week. I know we went over at least 1 and 2. Went over 1 and 2. We did 3 in person, like together. I think we did 3. Almost positive. Yeah, and then 5 and 6, I think you guys finished for homework. So what I'm guessing is I think 1, 2, and 3 we've reviewed enough. You guys should be good with that. I think we went over basically every parts of those. 5 and 6 then we'll do those today, I'm assuming. But if you guys want something cleared up, then by all means let me know. That's just what my guess is. So Jasmine says yes. Yeah, go ahead and give me some feedback if that sounds good. So go over the answers for 5 and 6. You guys can check your work, and then any questions you have after I go over that, we can do. Let's start with that approach. Thumbs up from Haber. Thank you, Alexis. All right, give it about a minute or two. So I don't know if you guys have heard a little update on news in case you guys haven't been paying attention or no one in your family's talked about or anything. But Governor DeWine came out, I believe it was yesterday, and discussed kind of some plans moving forward. So it looks like the 15th, so next Friday, um, there's going to be some more people getting back to work. So I saw I think it was next Friday. I can't remember. It was like barbershops, beauty salons, nail salons, like all that kind of stuff, like the self-care kind of places, should be opening back up. So a little bit of progress back to normal. I don't know about other businesses. How I didn't look into too much detail on it. Um, but yeah, I think things are starting to look up a little bit now. I'd like to hear your guys' opinion actually, but I don't know. I know personally, I'll give you my personal opinion. I don't, I'm not. I'm kind of torn because I think everyone innately wants to get back to normal and wants to start going out in public and doing things, and even if it means putting on a mask or social distancing, people just want to kind of return to a little bit of normalcy. And I get that, and I think obviously the economy's hurting, people are unemployed, not making money. There's a ton of issues, so it makes sense like there's an urgency to get back to work. But another part of me is like pretty terrified of that idea because nothing has changed. Coronavirus isn't any less contagious. We're not losing. We haven't flattened the curve. We haven't been cases haven't been decreasing. They're increasing. Deaths are increasing. Everything's increasing. So it seems like right now it's doesn't make too much sense to try to like go back to normal, especially because if it happens and it starts spreading like crazy again. All this was for nothing. So I don't know. I'm pretty torn. So yeah, if you guys have any opinions, I'd love to hear them. I don't know. I think it's important to talk about this stuff. Plus, I'm on my own, so I don't have unless someone calls me on a phone call or like a quick text. I don't really talk about it with too many people. So here's my outlet to get to talk to you guys. Alexis, I hate to say that. That's what's on your mind, Alexis. That's your concern, Cedar Point. Yeah, Cedar Point is going to take a huge toll on this. This is going to affect Cedar Point a huge way because there is no possible way I can foresee Cedar Point opening. There's no way. Yeah, exactly, Alexis. That's exactly what I'm thinking about. Like all Cedar Point is just people clustered together. It's like that's what the park is about. Like just people like shoulder to shoulder, whether they're on a ride or in line waiting for 2 hours for the Maverick, whatever it may be. Like Cedar Point is probably the worst spot to be open during all this, which is going to hurt them big time. Haber says, I would love to go back to normal, but no matter what, things won't be what they were. It won't be normal. Yeah, it just won't. And you know what? Like, honestly, a lot of people have said this, and I've kind of, at first I was like, but now I'm starting to kind of lean towards, I think a lot of things are going to change. I don't think it's just going to be like, obviously people are going to adapt to the situation. So for the short term, it's going to change. But I'm talking years down the line, like policies are going to start to change. Right? People are going to probably begin to plan for situations like this and implement rules in general just because it's good practice. There's a lot of places that don't follow good practice. And like maybe this is kind of a wake-up call, like, oh, maybe we weren't doing something right. Like letting just massive amount of people being close together and spreading germs and all that. But I don't know. I mean, I don't want to be negative about it. I think there's stuff you got to be positive about, but it's just at the end of the day, I don't. This isn't anything that's like gonna just end in a couple weeks. It's not like we all have like foresee what's gonna happen. No one knows how long this could take, how short it could take. No, there's just so. I think that's why people are so stressed out. It's just the lack of knowing, the lack of really understanding like where we're at, the lack of any sort of insight into the future. No one can see no one can make predictions. It's just so up in the air. Which I think, like personally, that's what stresses me the most about. If they said like it was I don't know about you guys, but my opinion was it was much more bearable when I knew like starting, what it was April 1st, we were supposed to get back to like school. Like it was very bearable because I was like, okay, 4 weeks or whatever it was. I don't know how long it was, but a couple weeks, or whatever it ended up being, I was like, okay, I can do this. And then they extended it like past our spring break, and I was like, okay, 2 more weeks, fine, I can do it. It's bearable. I have a date. Like I can circle on my calendar and say this is when things are normal again. And then they said, okay, May 1st. And now it's May 15th. And now, all these dates are approaching, but it's like there is no date that says, okay, now you can get out of your house and do whatever you want, Like it just hasn't, it's not going to be released. So that's my most stressful part, I think, of this whole thing. Lex, I feel like because of the snow days in the future won't exist, like the kids will stay at home, but we'll have school still. You know what? That's actually a really good point, Alexis. And I've thought about that, not in that sense, but I've thought about the idea, like me as a teacher, like this has actually been beneficial in some ways for me as a teacher. First of all, it's teaching me a skill of being online and, verbally teaching guys. And also I've been doing stuff like more lecture, which, as you know, being in my class all year, that's not what I do really. So I mean, I guess I don't ever plan on teaching like this, but if this is the case, I guess it's kind of diversifying that. But yeah, I'm gathering videos. Like all this stuff is, I just have like a bunch of videos now of content, and so like Alexis, next year if something happens where kids aren't in school for some reason, I have these videos. I could say, hey, instead of missing a day of school, do this assignment. Here's the video. Here's the solutions to the answers. Watch it, while you're working on it. And then I can save a day, which I don't know if it's going to eliminate snow days because teachers know how that is. Like I guess I'm speaking for myself, but I wouldn't want to burden you guys on a snow day because it's a snow day for us too. So unless it's something urgent, like I'm like, oh God, like I need us to do this or we're going to be toast, then maybe I would assign something. But yeah, I could see where we're going with that. That's an interesting take. The other thing I was thinking about that, Alexis, too, is just absences, teacher absences. If I'm sick one day and I have a sub, instead of wasting a day where everyone's in school and my sub just like sitting there and like that, people doing an assignment that's, I don't know, something like that, I could show them a stream. I could say, okay, watch the March 3rd stream or whatever, and then take notes and do the work while I go through it on the computer. I mean, it's kind of cool, and from that sense. I'm said I'm worried about not being able to go to college and learn a class we haven't do. Yeah, so that's guys, that's a very real reality for you seniors. I mean, it's a very, very real reality. Is that there's a high chance, at least for a fall semester, you might see yourselves taking strictly online college courses, which is terrible, horrible. Not this courses. I'm not saying that. I'm saying just like for you guys one of the coolest feelings ever is your first day of colleges. Like your first week of college, moving in, meeting your roommates. Like that's one of the coolest parts of college. One of them, like the best, but you'll still have the experience. It'll just be not right away. It'll be, either your second semester possibly, or maybe your just sophomore year. You'll still have the experience, just be a little bit postponed. But the good thing, like the little needle in the haystack bright side is the fact that you guys are getting practice now with online school. You guys have had practice for the last month or two. In everything I've done in my class specifically, I know for me, every class is different, but in my class, the class that you guys are taking right now, this is what you're going to have for online, except worse probably, which kind of stinks, but you're going to have teachers who are going to lecture through videos. I don't know if any of them do live stream, but maybe they will if everyone has to kind of adapt. So you'll see a lot of that. You'll be assigned videos to watch. You'll be assigned assignments, and you'll be given a date in the future to do them. So you'll have to 2 weeks to do one assignment or whatever it may be, and you can do it on your time. So I'm not talking about this to scare anyone. I'm not talking about this to freak anyone out. Like I'm just thinking, prepare for yourselves. Like have it in your mindset. Don't sell it be like, okay, for sure I'm going to be the first day of college. I'm going to be at campus. We're going to be going to class. It's going to be perfect. Like I don't know. I wouldn't tell yourself that. I would say, okay, there's a potential that I could be working online. And if that's the case, I'm ready for it. I've learned about it. I can adapt to it. I'll be fine. That's what I think your mindset should be. For me, I think it's crazy because now we're adults and it's a big change as it is. But with everything going on, it'll be even more of an unknown and a change. Yeah, really. Yeah, I guess the adults in quotations is huge. Sometimes I don't even know if I'm an adult. It's like you're constantly growing and maturing and learning things that you don't realize. And college is a huge step to that. And I guess not even just college, but where you guys are in your lives, even juniors, you too, where you guys are at your lives right now, you're kind of you're in this transition phase where you're trying to mature and become more of an adult and more independent and all that. And then all this crap gets unloaded on you. Yeah, it just... I feel very bad for you guys. I do. And I know that's probably not what you want. You don't want people feeling bad for you, but I do. I empathize with you guys. Makes me very sad to see everything. And you seniors especially. I mean, it's just horribly tough situation. So I commend you guys for how tough you are and how you're sticking it out. I mean, I'm very impressed with Vermilion High School, especially the students I see. So talking to you guys in my chat right now, you seniors, and then my BC seniors, like it's very impressive to see how you guys are handling this. So I commend you. Keep that up. It's going to go a long way. It's important skills. Anyways, I thought, it's always good to talk about this stuff. I think it eases mind. And today's the review day anyways, so we have 2 questions we'll review. I figure we'll have 45 minutes. We'll have plenty of time. So I thought I could kind of go off on a tangent a little bit. I see I didn't lose any viewers, so you guys were listening, not engaging. Maybe you muted me, so I would shut up. Whatever. So yeah, I'm going to give it a minute. Get out your, we're going to start with question 5 on the 2018 FRQ. So get question 5 out. Open the up on College Board and get your work out so we can start talking about it. Thank you for the likes, by the way. I'm seeing some people liking it. I didn't even have to beg you for it. Awesome. Much appreciated. Okay. So you should have your work open. The assignment is open. Number 5, just a reminder, this was the chemical reaction problem. So it's chemical reaction going on, modeled by derivative of y with respect to t is equal to negative 0.02 y squared. I will say, actually, guys, I hope it posted, but oh, thank you, Peyton. That's what I'm talking about. First thing doing in the morning is wake up, come like your video. That's what I'm talking about. That's the energy we need. I usually like my videos too. Just give me that one extra like. People don't know that. It's a little hint. So guys, question number 5, just so you know, I went over this on my yeah, I did. Okay, I went over part A and I believe part B. So 5A and B, I went over in the office hour from Wednesday. So if you guys still have questions, I'll still go over it. I don't have a problem with that, I guess. But I'll save that till the end. So 5A and 5B, when I give you the answers and talk about it, if you guys want to, I'm gonna wait till the end. If we have time, I'll go over it again. But I did talk about that twice, actually, on Wednesday. Emma and Andrew both came into my office hour and asked about it, and I posted that to YouTube just for that reason. So just keep that in mind. You guys can still ask for those questions. I'll still go over it if I have time. But if not, I'm going to do every other part first and then come back to those. Because at least I know then you can still get an answer on that, get a solution for that. Anyways, A. So using a line tangent to the graph at t equals 0, approximate the amount of substance remaining at t equals 2. So you wanted to first find the slope of the tangent line, which we know is a derivative. We're given a derivative already, dy dt. So we need to just basically find that at t equals 0. Well, in order to find it at t equals 0, we needed to find y. We know at time t equals 0, y is 10. Y is the substance present, so that's 10 grams. So you plug in 10 into the derivative equation, the differential equation, and you get negative 2 as the slope. Use point slope form. You get y equals 10 minus 2t. You plug in t equals 2, and you get y is approximately 6 grams. All right, so 5A is 6 grams. 5B didn't really involve any work. The only work you had to show was that the derivative is always going to be negative, no matter what y is. I don't care if y is negative a million. I don't care if it's a million. I don't care if it's 5. If it's negative 2, I don't care. It's always negative. Okay? The only time it's not negative is when y is 0. It's the only time it's not negative. But we're not really concerned about that. So the question was just seeing is this graph an appropriate graph for f? So what we have to decide is, well, the slope of f should always be negative. Because if the derivative is always negative, remember what a derivative tells us. The derivative tells us the slope of the original line, the original function. So if the derivative of f is negative, the original function should be decreasing. It should have a negative slope at all points. So your answer is that. this graph doesn't have a negative slope at all points. This graph eventually starts increasing, which it shouldn't. It should always be decreasing if it's an appropriate graph of f. I might have already said this, I'm not sure, but the reason why the derivative is always negative is because when you square, no matter what you pick y, no matter what y is, if you square, it's going to turn to be positive. So you have a positive value times negative 0.02 all the time, which is always going to be negative. So yeah, that's your answer. You could formulate that however you wanted to, as long as you got that point across. For part C, what we wanted to do was use separation of variables, excuse me, and solve. So separation of variables to get a solution, or expressing y. And so you get c equals negative 1/10. That was important. That was the first thing you needed to do, is use separation of variables, get c equals negative 1/10. And then solving eventually, just isolating y. And you end up getting y equals 1 divided by 0.02t plus 1/10, which is equal to 50 divided by t plus 5. You didn't need to rewrite it like that, but if you chose to, that was how you would rewrite the fraction. So again, 1 divided by 0.02t plus 1/10 equals y. D wanted to see if the amount of the substance is changing at an increasing or decreasing rate. All right, so we want to know if the rate is increasing or decreasing, which means we have to take the derivative of the rate. Well, the rate's represented by dy dt. So to take the derivative of dy dt, it's dy squared dt squared. So we need to find the second derivative. So you take the second derivative, you get negative 0.04y times y prime. From there, basically, we can simplify that if you want, because you know what y prime is. So you'll plug in y prime, which is negative 0.02y squared, combine everything, and you end up getting 0.0008y cubed is your second derivative. Your second derivative equals 0.0008y cubed. And the actual question said, is it increasing or decreasing? Well, y is the amount of substance, so when y is greater than 0, meaning 0.0008y cubed is always going to be positive. Because the amount of substance isn't going to ever be negative. You can't have a negative, like I can't have negative water, or negative air, or negative chairs. I don't know, I'm just trying to think of substances, all right? Whatever, they can't be negative, right? So if they're negative, that doesn't make any sense. That means it has to be greater than 0, so y has to be greater than 0. And a positive times a positive will always be positive, which tells us it's an increasing rate. All right, that was number 5. Go ahead and type in the chat. If you had any questions on 5, go ahead and type in the chat now. Don't submit it. Don't press enter. Just have it there ready. So after I go through 6, you can add your questions from 6, and then you can enter them all at once. So just type them in the chat now, real quick, and don't enter. Just keep them there. And then look at your work for 6. All right, so 6 says consider a curve. So we got this curve. Remember when they say curve, it's just basically telling you like, hey, this isn't like a typical line or anything like that. That's what a curve is. Just ignore that part. But you can tell this equation isn't like a y equals equation or a dy dt equals. It's kind of a mixed equation with different types of functions. It says for all the points on the curve 2/3 to 2. Show that dy dx is equal to 2 divided by 2 minus sine y. Okay, so I can't really tell you the answer for this. I'll just kind of explain how you get there. So essentially what you're doing is you're taking the derivative of 2 times x minus y equals 3 plus cosine y. So you're going to use implicit differentiation. What I would do is I would have distributed the 2. So make it 2x minus 2y equals 3 plus cosine y. Use implicit differentiation, go through that process, and you're going to eventually factor out a y prime, divide by whatever's left over, and then you prove that that's true. So that's something like if you guys couldn't do that, basically, just tell me, and that would be something we could review. But, yeah, no real answer for that, right? So for B says for negative pi over 2 to pi over 2, there's a point P on the curve through which the line tangent to the curve has a slope of 1. Find the coordinates of the point P. So what we wanted to do was we wanted to take 1 which if we know that the curve, the tangent line has a slope of 1, that means the derivative is equal to 1. So we take the derivative, which we found in 6a, we set it equal to 1. All right, and then we solve that. And we solve that because we know our point has to be contained somewhere in there. And that point specifically is the y variable. We want to solve for y. So we have this equation, 1 equals 2 divided by 2 minus sine y. And we go through and we solve that for y. So you multiply by 2 times minus sine y. You subtract 2, and then you just solve that, and you get y equals 0. But it says find the coordinates of the point. So to find coordinates, we don't only need y, we need x. So at y equals 0, we got to find what x is. So we plug y equals 0 into our original equation, not the derivative, into the original equation to find x. And when you do that, pretty easy math, solve for x, you get x equals 2. So your final point, your answer for B should have been 2, 0. C, determine the concavity. The second you read that, just think second derivative. Just dive right in, second derivative. So we have the first derivative is 2 divided by 2 minus sine y. Second derivative, you take the derivative of that. So you use quotient rule. You actually didn't necessarily need to simplify, but if you did, you should have gotten the second derivative is equal to 4 cosine y divided by the quantity 2 minus sine y cubed. That's what it would have all simplified down to, which would have been useful, but the question is then determine the concavity based off of that. Well, we know that final derivative, that second derivative, is always going to be greater than 0, and here's why. Because we know the numerator is always going to be greater than 0, because cosine of y between negative pi over 2 and pi over 2 is always going to be positive. So the numerator is positive. We know the denominator is always going to be positive too, because sine of y, no matter what y is in that interval, negative pi over 2 to pi over 2, it's always going to be less than 2. Which means that 2 minus a number that's less than it will always be positive. So again, it'll be positive number cubed, which will be positive. So the numerator and denominator are both positive, which means that it's concave up. The second derivative is always positive on that interval. So concave up. And then finally, part D. Part D is a bunch of words, looks really complicated. The actual math for it's not too bad. You had to start with the fact that they said use the mean value theorem. The mean value theorem is saying that f prime of c is equal to the average rate of change on your interval. We find average rate of change by finding the slope. So f prime of c is equal to f of 2.1 minus f of 2 divided by 2.1 minus 2. Now the tricky part of D was just what do we go from there? So once you get that settled, you have to then use the information they gave you at the beginning of the problem. They told you that every single derivative is between 2/3 and 2 for all the points in the curve. Which means that f prime of c has to be between 2/3 and 2. And if f prime of c equals the average rate of change, that means that f of 2.1 minus f of 2.1 minus f of 2 divided by 0.1 has to be between 2/3 and 2. And then you multiply by 0.1 and you get your answer. So that one's a little hard for me to talk in person. Again, if that's something you'd want to go over, put that in the chat. All right, so that's all the answers. Go ahead, guys, submit your questions, and I will start going over them on paper rather than describing them. Andrew says 5C, all of 6. Okay. Peyton says 6C. All right. 5C and just the second derivative of 6C. Okay. Don't be shy, people. So it looks like we're definitely doing 5C. That's where we'll definitely start. Well, I'll just get started then. And if you guys have any questions, please don't, keep typing. So 5C, let's go there. Let me open up the question. This is separation of variables. So it says to determine or find the expression for y equals f of t by solving the differential equation. Whenever you guys see the word solving the differential equation, think to yourself separation of variables. Okay? Solving a differential equation and requires separation of variables. It's the only tool we have. There's more, but that's the only tool we have, really. So we gotta dive into that. And to do that, I'm just gonna write the problem out again. Okay. So separation of variables means what it sounds like. We need to separate the variables. So I need all the dy's and y's on one side. So I divide by y squared. And I need all dt's on the other. When I look at dt, I'm treating that as a independent variable. So I want the constant to be with it. I want the negative 0.02. So just like if it was dy dx, you would always put the constant with x. All right, so I'm left with this. I separated the variables. Now I actually have to integrate. So if you guys remember this step, you would integrate both sides. And I get negative y to the negative first is equal to negative 0.02t plus c. Remember, it's an indefinite integral, so we have to add that c. I'm going to rewrite this. Instead of negative y to the negative first, I'm going to do negative 1 over y is equal to negative 0.02t plus c. And they give us the initial conditions 0, 10. So in order to find c, we're using the point 0, 10. Which means it's going to be negative 1/10 is equal to negative 0.02 t when t is 0 is 0. So negative 1/10 equals c. All right, after you find that, now what we want to do is actually get our equation. It says find an expression for y by solving the differential equation. So now we need our expression. So we're going to take this step here, and we're going to rewrite it, except replacing c now. So now we have negative 1 over y equals negative 0.02t minus 1/10. I'm going to multiply everything by y. And then divide by the blue. Okay, this is just basic algebra. Don't think you guys need too much help with this. Oops. That's just 1, 0. T minus 1/10 equals y. I know that got really messy. I apologize. It's a problem with using my pen. So this is negative 1. So divided by that, it's negative 1 divided by negative 0.02t minus 1/10. And that can be our answer. No point in doing any more work from there. If you wanted to keep going, that can be all positive, because if you factor out a negative from the numerator, right, that becomes a negative out front. If you factor out a negative from the denominator, you get a negative out front. You can cancel those out. And you can also write your answer like this. So 1 divided by 0.02t plus 1/10. That's also an acceptable answer. All right, so that was 5C. Any questions on 5C? Go ahead and give me a thumbs up or let me know you're good. We can move to number 6 now. Patented Emma Haber, thumbs up. Thank you. Move this over. Good. All right. So let's look at 6. I have enough time, so I'm okay with just going over number 6. But first, I need my camera to look better. I think that'll work. Okay. So yeah, let's just take 6 step by step. So it says consider this curve. I'm just gonna write it down. I like to have all my eggs in a basket. Is that an expression? I think so. For all points on the curve, 2/3 dy dx less than or equal to 2. First of all, I want to mention this, and I know I forget who I was talking to. I think it might have been Haber. I think maybe Emma came in on Wednesday and asked about part of this question, part D, I believe. And I told her this, and I want to reiterate this because I think this is important for you guys to think about. The AP will not give you information you don't need. Every information is relevant. So sometimes it's relevant because it has to be said, or whatever they're typing, whatever their question is, doesn't make sense. And sometimes we can ignore pieces of information because of that. It's just like kind of, they're just doing it just to be proper with their notation. Other times, though, you get information like an interval. This is a perfect example, an interval, maybe another formula, like whatever it may be, and there's always a reason for it. They're not going to give it to you for no reason. So right away, you see this equation. I think probably you guys are reading this in your mind. I know mine does. Immediately just goes like, okay, that's my key. That's the key to this problem, is that equation right there. Like, I don't even need to read the question. I know that I need to use that. The part that's a little bit less obvious is that interval there, because we haven't seen that interval used very often, first of all. But second of all, it just seems like, I don't know, when you guys see it, hopefully it stood out. You're like, that's kind of strange. And we don't need it right now, but we're going to need it later. So just keep that in mind. They're not going to give you information you don't need. So when you, on your AP test, and you read something, it's there for a reason. Anywho, we want to show that dy dx equals 2 divided by 2 minus sine y. In order to do that, first we need to find dy dx. So you don't need to include that in the red. I'm just showing you on paper what I'm doing. All right, and that means the derivative of this equation. So I need to find the derivative of that equation. So I'm going to start by, I'm going to just distribute the 2. I'm doing that, it just makes the derivative part easier. So now we're taking the derivative. This derivative is with respect to x. Derivative of y with respect to x. We have to use implicit differentiation because we don't just have a y equals statement. We have this stupid cosine, which makes things more complicated for us. So we have to take the derivative of y with respect to x, which means everything's with respect to x, which means the derivative of 2x would just be 2 because it has an x in it. Derivative of 2y is going to be minus 2 y prime. Think of it as using chain rule. The derivative in general of 2y is 2. Derivative of y is y prime. Derivative of 3 is 0. Derivative of cosine of y is going to be negative sine of y times y prime. So again, the derivative of cosine in general is negative sine, and then the derivative of y is y prime. We're treating y as a function of x. Okay, and I'll keep going just for good measure. I'm going to get all of the y primes on one side, because ultimately I'm looking for y prime, or dy dx. Those are the same thing, y prime and dy dx. So in order to solve for it, I need to get it on its one side. You know, this is just algebra. So I need to get it on one side of the equation. I need to factor out a y prime. So it's all by itself. Whoops, I don't know why I put 2 sets of parentheses, whatever. So 2 equals y prime times negative sine y plus 2. And then divide by everything to get y prime by itself. So 2 divided by 2 minus sine y is equal to y prime. And that's what they wanted you to prove. All right, that was 6/8. Implicit differentiation, big key. They're testing you on that. Go on the chat, type if you want me to come back to that. That's fine. I'm going to keep going. 6B. Let's take a look at that sucker. So 6B, this is the one where they say for the interval negative pi over 2 to pi over 2, there is a point P on the curve through which the tangent line to the curve has slope of 1. Find the coordinates. All right. So that means if the tangent line of the curve has a slope of 1, that means dy dx is equal to 1. That's just a piece of information they give us. We know anytime we see tangent lines, we have to think derivatives. So the slope specifically is going to give you the derivative. All right. So now what we want to do, now that we know this information, is replace dy dx. We just solved for it. It's 2 divided by 2 minus sine y. So what we're really working with is 2 divided by 2 minus sine y equals 1. I'm looking for a coordinate of P that has this tangent line with a slope of 1 on this interval. So if I'm looking for a coordinate point, what I need to do is I need to solve this equation. I know this is true. I can solve for what y value makes this true, right? I need to solve for what y value makes this true. So I multiply by 2 minus sine y to both sides. I subtract 2 from both sides. And then I just need to look at this and think unit circle. So I know this is hard for a lot of you guys. And this is a huge important skill, calculus, and hopefully we're getting better. And the AP test coming up, so you need to be ready for this. But you'll have a unit circle at least. Well, all I'm seeing is, okay, where does x equal 0? In this case, where does x equal 0? And there's a lot of answers for that, right? It could be at pi over 2. It could be at 3 pi over 2. It could be at 5 pi over 2. It could be at 7 pi over, and then you can keep going on forever and forever. But this question specifically says from negative pi over 2 to pi over 2. Also, I just realized I was speaking incorrectly. There's a lot of different answers. I was thinking the x value. When the y value is 0, there's a lot of answers, right? Because whenever we're looking for sine, we're looking at the unit circle when y equals 0. So that's at places like 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi. So there's like infinity answers. But this question specifically says for the interval negative pi over 2 to pi over 2. Y is between that interval. So where in that interval is this true? There's only one answer, and it's when y is 0. All right, now we need to find a point, so we need an x value. So at y equals 0, we have 2x minus 0 equals 3 plus cosine of 0. This was the original equation. We're looking for a point on the original equation, so we have to plug in to solve for x. So we get 2x equals 3. Cosine of 0 is the x value at 0, which is 1. Plus 1. So 2x equals 4, x equals 2. So your final answer is 2, 0. That's equal to p. That's your point. Again, go ahead and type in the chat. I'll come back to that if I need to. If you have any questions on that. All right. Part C was one of the most, this was the most math involved for this question, I would probably said. Determine the concavity. I already talked about this. You'd think concavity, think second derivative. So I need to find this second derivative. In order to do that, I'm going to take this first derivative. So I'm just going to put this in blue just so you know where I'm referencing. That's the first derivative, so I need to take the derivative of that, which is the quotient rule. Move this up a little bit so you guys can see. Move it down just a little bit. Okay, so low d high minus high d low divided by low squared. So low is 2 minus sine y. Derivative of high is 0 minus high is just 2 times the derivative of low, which is negative cosine y. Now the big kicker here, times y prime. We're still using implicit differentiation because it's still with respect to x, which y is a function of x. So the derivative of 2 minus sine y is 0, and then negative cosine of y times y prime. So that might have been a snag in your answer. Make sure you check your work if you got that correct. And then all divided by low squared. So 2 minus sine y squared. To simplify this, because right off the bat, you actually could go through and you could probably find the answer. It's just going to be a pain in the butt. So instead, we're going to simplify this down just to make our lives a little bit easier. And this whole thing turns to 0, the first part of the numerator. Second part becomes 2 positive cosine of y, because negative 2 times negative cosine is 2 positive cosine. And then instead of y prime, we can replace that back with 2 minus sine y, or 2 divided by 2 minus sine y. And that's still all going to be divided by 2 minus sine y squared. Okay, now these are being multiplied in the numerator. So I'm actually just going to do it on the side here. I can multiply those together and I get 4 cosine of y divided by 2 minus sine y divided by the quantity 2 minus sine y squared. And now I got this complex fraction that's really annoying looking. In order to simplify that, remember you're just taking a fraction divided by a number. So you can multiply by the reciprocal. So a fraction, 4 cosine of y divided by 2 minus sine y, times 1 over 2 minus sine y squared, which is going to give you 4 cosine of y. 2 minus sine y times 2 minus sine y squared is 2 minus sine y cubed. So that's kind of how I got that simplification for you when I read off the answers. And here's the important notes to make. You don't need to say this. You can just describe it, so you don't really need to like break it down like this, but I think it'll be useful to you guys, so I'm going to. Remember the question. The original question was concavity. That's why we did the second derivative. So after you do all this work, you might get lost and be like, why did I just do that? Well, remember, we started this because concavity. We want to know more about concavity. So in other words, the second derivative tells us concavity because if it's positive, it's concave up. If it's negative, it's concave down. So we have this interval from negative pi over 2 to pi over 2. Is 4 cosine y on that interval, what is that going to be? Is the numerator going to be positive or negative? Let's think about the unit circle. I'm just going to draw it real quick down here. We're looking from here to here. That's from negative pi over 2 to pi over 2. So just that right side of that circle. Cosine is going to be all the x values. What are the x values on the right side of the unit circle? These are all positive x values, right? X equals whatever along that x-axis. It doesn't matter. They're always positive. So 4 cosine of y is always going to be greater than 0. Now let's look at the denominator. All I care about is sine of y. 2 is a constant, cube's a constant. The only thing I'm worried about is what's happening with sine. That's the y value. Well, remember, your unit circle bounds it from negative 1 to 1, right? So it doesn't matter. My y at the very most can be 1, at the very least can be negative 1. This sine of y can at the most be 1 or at the least be negative 1. So regardless of what you get, it's always going to be less than 2. 2 minus 1 or 2 minus a negative 1, whatever you get is always going to be positive. Sorry, I guess the better way to do this would be sine of y is going to be less than 2. That's really what we're saying, which means that 2 minus a number less than it is always going to be positive. So at the end of the day, You would write that out. So I guess your final answer, here, I'll write out the final answer you'd want to put. So d2 dy dx squared is greater than 0 for all values of y on the interval negative pi over 2 is less than y, which is less than pi over 2. So, concave up. That would be like the formal answer right there. So like this part, I just want to show you guys how I got there. This is all you need though, is get the second derivative, state that the second derivative is greater than 0 for all values of y in the interval. So it's concave up. I'm going to take a second, let you guys copy that down if you need to. One thing I'm going to point out, just because now it's on my mind, is for a lot of you guys' FRQ responses, by the way, make sure you're still checking those. I do put a lot of time and effort into grading those and giving you feedback. Like a lot, takes a lot of time, a surprising amount of time. So yeah, I hope you guys are looking at them and reflecting on them. One of the reason I'm bringing it up is because a lot of issues for people is explanations. So justifications is a huge part in this test, which means like this point, if I were to score you guys on this question, you have to, one of the points is giving a reason. So it's probably 2 points. First point is getting the second derivative is equal to this. The second point is your explanation. Your third point actually would be your answer. So you would get 2 points by just doing this. Your last point, though, to earn the last point, you need this explanation. And that's where I'm seeing people are faltering, is the justification, which at the end of the day is entirely just understanding concepts of calculus. So I just want to make sure, guys, like don't skimp out on those. Some people I know are doing it because they're like, oh, Mr. Harris will know what I'm doing. Like he'll understand. It's cool. Just for the AP test, know that I'm not grading it. It's some random person who's probably going to be very stingy. So just be as specific as possible without doing stupid, like saying stupid things that are too detailed. So make sure you know, give a reason for your answer. Don't just say it's concave up. Justify it's because the second derivative is greater than 0. Anyways, part D. You probably should have enough time now to write that down. Let's look at part D. Again, part D doesn't have a ton of math involved. It's all concept. Just understand what the question's asking. So they say that let y equal f of x be a function defined implicitly. So they give us the function. It's continuous from 2 to 2.1 and differentiable from 2 to 2.1. That whole point, like that sentence, it's continuous and differentiable. Only reason they said that was because that's the only way we can use mean value theorem. The mean value theorem, the definition of the mean value theorem, it only applies if the function is continuous on a closed interval and differentiable on an open interval. It's the only time it applies. So that's why they said that. That's one of those situations where that information is, you can gloss over. It's not something that you need to apply, but you can gloss over it. Use the mean value theorem on the interval from 2 to 2.y to show whatever. Okay? So, using the mean value theorem. Mean value theorem states that f prime of c is equal to f of 2.1 minus f of 2 divided by 2.1 minus 2, which is equal to f of 2.1 minus f of 2 divided by 0.1. That's what the mean value theorem is stating. So let's just start there. It's a good place to start. Now it takes a little conceptual understanding. What is f prime of c? F prime of c is a derivative at a given value c on the interval 2 to 2.1. So c, whatever c is, it's between 2 and 2.1. And it's a derivative. It could be 2.01, it could be 2.02, it could be 2.05, whatever. It could be any of that. If you look at the beginning of the question, this is why I said this at the beginning of the question, we're given this piece of information that every single derivative on this curve is between 2/3 and 2. Which means this derivative is included in that. F prime, the derivative of f at the point C also has to be greater than 2/3, but less than or equal to 2. That's what the question told us. That was the information that was given to us. I don't know what C is, but I don't care. I just know whatever it is, it has to, the answer for that, or the y value has to be between here. We don't have a choice. Which means that if f prime of c equals this expression, then that expression, f of 2.1 minus f of 2 divided by 0.1 also has to be in that interval. So the average rate of change also has to be greater than or equal to 2/3 and less than or equal to 2, because that is equal to f prime of c. All right, and then just solving a interval, I guess, you want to multiply 0.1 to both values. So 2/3 times 0.1 is 1/15. When you multiply this middle fraction by 0.1, it gets rid of 0.1. So you're left with just f of 2.1 minus f of 2. And then 2 times 0.1 is 1/5. And that's what they wanted us to prove. That was what the question wanted us to prove. And we achieved that. If you were like, well, how'd you know that? We have a calculator. But if you wanted to multiply by 0.1, that's the same thing as 1/10. So 2/3 times 1/10 is 1/15. 2 times 1/10 is 2/10, which is 1/5. So without a calculator, that's how you could get there. All right, and that is your assignment, people. How do we feel? Give me some thumbs up, thumbs down, happy, sad, indifferent. Good, good. All right. So like I said, guys, this is good for you. So now all of 6 you should be good with. 5. If you're still confused on, what did I say, 5A and 5B, I gave 2 different explanations that were very, very similar, if not almost the exact same, on my office hour on Wednesday. So if you want to see my first explanation, it's towards the beginning of the stream. My second explanation with Emma was about the last probably 10 minutes, I would say, ish. So if 5 is still bugging you, that's what I recommend doing, just for the sake of me not having to repeat myself 3 times. If that doesn't do it for you, though, please, by all means, ask me and I can try harder to make it clear. But I figure I'll let you guys try looking at the video first. That way, if that's good enough, I don't have to just repeat myself. A couple things to talk about before you guys get out of here and enjoy your weekends. Number 1 is this homework the weekend. So I kind of told you I would give you some more information, which I did. It's posted to Google Classroom. So I gave you guys this worksheet on Google Classroom. Here, I can actually tell you what. I'll pull it up real quick. It posted yesterday, so I don't know if you've looked at it. So here's the post. It says, here's Mr. Harris's recommendation for preparing this weekend. I also tested a checklist. So there's this Google document you can click on. Hopefully you can see it. I don't see why you wouldn't be able to. Can't edit it, but I think you can see it. So I just said the following list I'd recommend to do this weekend. None of it's graded, just what I believe could be useful to you. So this was all just me thinking like, okay, if I were to prepare for this test, or if I were to assign this test, what would I want my students to do to prepare for it? And this is all the information I got. So there's, 13 things, different things to look at. This isn't something you get to follow word by word. It's not something you have to turn in any assignments for. None of that. It just I only put this because I wanted to help you guys. So I said, here's the most important things I think they need to do this weekend to be ready, and I put them on here. Most of it isn't content. I don't even put content stuff till the very end. I really want to make sure you guys are just ready to take the actual test. Make sure you take this demo test. That's number 1 on the list. I really think that's super, super important. Take a demo test. Get used to plugging all that in. Make sure your computer runs with it, like all that stuff. That's got to be the first thing you do if you haven't already. Hopefully you already have. Number 2 was to do this AP exam day checklist. I would really like it if you guys went through this. I posted that along with this on the post I made, and I gave you this checklist. Looks like you might have to download it. So you have to go like to these 3 dots up here, maybe. I don't really know. Let me know if you guys have any issues with that. But if you do, it's okay. You can find that on the AP website. So go to College Board and search exam day checklist, and you'll find it pretty easily. So if you can't access it on my Google Classroom, you can also go to AP to find it. That's super important as well, going down that checklist. Everything else you guys can read. But yeah, that's just my help for you. The last thing I want to talk about before you guys get going is I also posted this survey. So Monday's our last day. We'll be able to go over anything in person, like over the stream. So I want you guys to fill the survey out and let me know, hey, Mr. Harris, I would really appreciate it if we went over derivatives, integrals, whatever it may be. So yeah, go ahead and do that. If you guys can too, I forgot to put a portion for your name. You don't have to put your name if you want to be anonymous. Not that I feel like it, I'm not going to judge you, so I don't know why you would care. But if you feel the need to be anonymous, go ahead. If not, try to remember to put your names. It makes me curious because I want to know individually, guys, where you're at, and I want to be able to help you individually if need be, as well as a team or as a whole. So please, I really appreciate it. It'll make Monday worthwhile if you guys can do that. If not, I'll just pick random things, and I don't want to pick random things because then I might be wasting my time or wasting your time, more importantly. Okay, think I got everything. So now I'm done holding you against your will. You are good to go. Have a fantastic weekend. Miss you all dearly. Hope all is well at home. Hope that you guys are doing well. Next Tuesday's the big day, people. It's a day we circled on our calendar from the very beginning. I'm nervous, to be honest. A little nerves is good. I just really hope you guys do well. I'm really looking forward to it. Excited to see your results of all your hard work. So keep that in mind, guys. This weekend, don't panic. Don't overthink it. You guys are ready. We've done plenty of practice. I've seen your work. You guys are ready. You're gonna do good on this. So have that mindset. Treat this weekend as a way just to shore up some final things. Have a great weekend, Haber. Appreciate it. Thank you guys for stopping by. I do appreciate it quite a bit. It makes these streams worth it, so thank you. Hey, Isaac. Good to see you. All right, Isaac, good to see you too. How's quarantine? Oh, Isaac, just a blast. Just loving every second. No, it's quarantine. A little bit miserable. trying to fight through it. How's it going for you, Isaac? More importantly, how are you doing? Keeping busy, playing FIFA, playing Call of Duty, maybe reading books, doing math homework all the time. What's been your quarantine mood? Quarantine what's the word I'm looking for? Activity. Really good playing Rocket League. Oh, Isaac, you understand two of my favorite things in this world are Rocket League and basketball. So you are just speaking my language. So Isaac, I know we talked about this before, but I actually didn't even know you played basketball. But are you considering or you are going to try out for basketball next year? You're trying out. Okay, so Isaac, we have a Google Classroom for our basketball players, and the Google Classroom is just a spot where we can um, kind of communicate with all of our players. And I've been posting ball handling drills a couple times a week, shooting drills. We have a 10,000 shot club, so you can chart all the shots you're taking. We have a leaderboard. Like, we got a ton of stuff going on up there. Would you be interested in being invited to that? And you can join in and you can participate. Because if you're trying out, man, we got plenty of resources for you that we've been working on, and by all means, we can get you in that Google Classroom. You can start participating. But you let me know. I'll make a note right now, and I'll send you an invite. Okay. Has he given you the code, Isaac? Or like, do you need it? Because I can give it to you. Okay. Cool. I'm making a note right now. So Isaac, I'll be in touch with you. I'll just email you the code and everything. I'm not gonna do it right now just because my internet's so bad I can't even really access too many things. But also, I'm technically teaching right now, so basketball's gotta wait. But in about at 12 o'clock when I'm done with my office hours, I'll look into that. I'll email you the code, get your email and everything, and look for that. So yeah, that's awesome. Good to hear. How's Rocket League? What rank are you in there? Veteran. What rank is veteran in Rocket League? Probably for about a good 2 weeks. I guess veteran would probably be like platinum or something. I don't know. Yeah, I like Rocket League a ton. Usually with Rocket League, that's my way. Like, I treat Rocket League as like my stress reliever because I can't play basketball. So usually basketball is like my outlet. If I'm like just bored or like stressed out or just need my mind to like not be thinking, I'll go play basketball and just shoot for hours or play one on one, whatever. But since I'm in quarantine and can't do that, I have to do Rocket League is kind of my other. So I'll just turn on music. I'll just blast music and just play Rocket League kind of mindlessly. I enjoy it. All I know is you have to play a lot. Yeah. Yeah. Oh man, I've never looked. I don't even want to look at how many hours I've put into that game. I've been playing it ever since I got my Xbox. It's like the first game I got for my Xbox. I've been playing it so much. Love it. Yeah, Xbox. I used to have a PlayStation. The reason why was because when I was in high school, I had to pay for most things. So the PlayStation used to be free online, which was like the only reason why I did PlayStation. All my friends had Xboxes for the most part, but I convinced some of my buddies to get PlayStation. Anyways, then that changed, and I realized Xbox is the better system, and more people are on it, and more of my friends are on it. So I was like, I gotta just get Xbox. Why am I still using PlayStation? The real way to go is PC though, but I just don't have the setup for it. Yep, Xbox is the way to go. I'm telling you. Well, anyways, Isaac, I'm sure you came in here probably with a question, so go ahead and let me know what you were wondering about. All right. I need a little step by step. Okay. I try to do good. All right. So Isaac, I'm gonna post something really quick. Sorry, just give me one moment. So I'll tell you, Isaac, just because you're here. I'm giving this as an extra credit assignment. So just so you're aware. Yeah, I'm gonna give it an extra credit assignment because I completely forgot to post the assignment to Google Classroom. So I'm just gonna make it extra credit. So if you turn it in, you'll get extra credit for it, which is good. You know, extra credit's always fun. Just so you're aware. But yeah, let's look at. Do you have a specific question that you wanted to do? Oh, hey, Maddie. No, the answer then I guess would be it doesn't. I mean, I prefer you complete it. It would be good. It's great practice. I didn't assign it for no reason. So yeah, go ahead and complete it. But if when you submit it, I'll give you extra credit for it. So instead of being worth 4 points, it'll just be 4 extra credit points. So it'll be a boost to your grade if you want to look at it that way. But to answer your real question, Maddie, if you don't submit it, nothing will be counted against you, is what I'm getting at here. Okay, I think you said number 11. All right. So give me a second, Isaac. My computer gets so annoying with this book when I'm trying to stream. Okay, I think that should be good. Because I know that I'm doing pretty well in your class. Or struggle with picking things out and word problems. Yeah, you're not alone, Isaac. Trust me. Everyone does, myself included. All right, so 11. Let's take a look at that. So it says work. Kendall and Shandy. Yeah, I think I'm saying that right. Kendall and Shandy wax cars. Kendall can wax a particular car in 60 minutes. Shandy can wax the same car in 80 minutes. They plan on waxing the same car together and want to know how long it'll take. How much will Kendall's complete in 1 minute? So, basically what we're saying is this. She has, what's her name? Kendall with a K? Kendall. All right, let's take a look at Kendall. She can wax a particular car in 60 minutes. So that means we're looking at how many cars can she wax per minute. That's the rational expression we're going to set up. Well, the number of cars in specific for part A, so this is part A, how much will Kendall complete in 1 minute? The cars, we're wondering, we're not sure. We know it takes 60 minutes to produce one car. Okay, let me back up actually. That's still something useful to use, but let's rewind. How much will Kendall complete in 1 minute? Well, if she takes one car is 60 minutes. So let's actually reverse this. Cars or minutes, sorry, keep messing this up. And over cars. Oh, you can't even see my paper. I'm so stupid. I apologize for that mess. Okay, so she has, how many minutes does it take for car? We know it's going to take 60 minutes per one car. So we want to know how many minutes it's going to take, or when it's 1 minute, how many cars. So basically 1 over x. So if it's 60 minutes for one car, then what's going to be 1 over 1 minute for how many cars? All right, and so essentially, instead of putting that arrow, these have to be equal to. This is a proportion. These are proportionate, is what we call them. If it's minutes per car, 60 minutes per one car is going to be equal to 1 minute for how many cars? X. So we solve that. We cross multiply. So it's going to be 60x equals 1, which means x equals 1 over 60. So that would be your answer for A. How much will Kendall complete in 1 minute? 1 out of 60. 1/60th of a. She'll complete 1/60th of a car, which it may be the first portion of the windshield is what she'll complete in 1 minute. All right, let's look at part B. Part B says how much will Kendall complete in X minutes? Same idea. Okay, but in this case, if it's 1 over 60, notice in 1 minute, that's our numerator. In 60 minutes, it would be 60 over 60, and we'd be one car. So how much she'll compete in X minutes is going to be X divided by 60. So we're kind of using 60 as like our baseline. If she completes one car every 60 minutes, that's going to be our denominator. So she'll complete an X amount in X minutes. C and D are the exact same question, except a different person. It's Shandy. So Shandy will complete 1/80th of her car in 1 minute, because it takes her 80 minutes to make one car. So in 1 minute, it'll be 1/80th of her car will be done. In X minutes, I don't care if it's 7, 8, 20, 50, 75. Whatever that number is, this will be the fraction of the amount that she's completed. That number of minutes divided by 80, because 80 is the baseline. Let me just stop there, Isaac, before I keep going. Are you okay with those? I don't think my explanation was fantastic the first time through. Just let me know how you feel. Yeah, your explanation wasn't the best. I got the far cross. I'm good. Appreciate the honesty, Isaac. Yeah, I think the biggest thing, the way I see it, the easier way to look at it is just think about this as like 60 of 60 for, what's her name? Kendall, would be one car, right? So if 1 minute out of the 60 minutes would just be 1/60th of her car. She's basically, figuring out each portion. Part E is now going to apply more so of what we've been doing in this chapter, which is create a rational expression that models the situation. And this situation I'm talking about is the situation of Kendall and Shandy working together. So they combine their talents to go wax one car. Well, we know that depending, it's dependent on how many minutes they work on it. We know that however many minutes they work on it, however many minutes Kendall works on it, which is x over 60, she'll complete x over 60 of the car. Shandy will complete x over 80 of the car. Regardless, we don't know what x is right now. We don't know what the exact answer is, but we know that whenever you add those up, it's going to have to equal one total car. So the proportion x over 60 plus x over 80 has to equal 1. One car. So we kind of want to figure out how many minutes do each of them have to spend on it to finish the car, essentially. And that's what part F is saying. So part F is saying to solve the equation, determine how long will it take them to finish the car. So you look at this, and we want to get a common denominator between 60 and 80. So basically between 6 and 8, what is their common denominator? And that's going to be 24. So which means our common denominator here is going to be 240. So 60 times 4 is 240. So I have to multiply 4 into the numerator. 8 times 3. 80 times 3 is 240, which means I have to multiply the numerator by 3. And then this will just be 240 divided by 240. Right, because 1 has to have a denominator of 240, you have to multiply the numerator as well. Which means 4x plus 3x equals 240, which means 7x equals 240, which means x is equal to 34.3 minutes. How do you feel about E and F, Isaac? Those good for you? Yeah, okay, cool. Yeah, this problem didn't really apply what we did this chapter till E and F, but A through D you did get to create these fractions, which are rational. All right. So I mean, there's 4 people, looks like, in here. So if anyone else is being quiet and has questions, go ahead and ask. Huh. 9A and B, sure. Let me flip this page over. Okay. So we have Sarah with an A has 10 pounds of dried fruit selling for $6.25 per pound. She wants to know how many pounds of mixed nuts selling for $4.50 per pound she needs to make a trail mix selling $5 per pound. Let M be the number of pounds of mixed nuts. Complete the following table. All right. So we have pounds. Let me give myself more room. We have dried fruit. We have mixed fruit. Oh no, sorry, mixed nuts. And trail mix. Up here we have pounds, price per pound, and total. Yes, I realize it's messy. It's okay. Okay, so what's given to us is there's 10 pounds of dried fruit. It goes for $6.25 per pound. And the total then would be $6.25, which is per pound, times the total number of pounds, which is 10. So $6.25 times 10. That's all given to us. That was given to us in the original question. What she wants to know is how many pounds of mixed nuts. And that's going to be represented by M. M is the number of pounds of mixed nuts. So pounds, mixed nuts, we put an M there. Let me do it in a different ink. So M is going to be there. So we know that just by looking at the question. Okay, what else do we know? We know that mixed nuts are selling for $4.50 per pound. So 4.5 is going to be the price per pound. To get a total price, you take the price per pound times the number of pounds. So 4.5 times M. Let's keep going. The trail mix. The pounds of trail mix is combined dry fruit and mixed nuts. So we don't know how many mixed nuts we have, but we know that 10 plus however that much is going to be the total number of pounds. So the trail mix pounds is going to be 10 plus M. The price per pound is given to us. In the question, they tell us that she needs to make trail mix selling for $5 per pound. So the price per pound is $5. The total price is going to be those two combined, right? The price per pound times the number of pounds. So 5 times 10 plus M. All right, that's all the work for 9A. Just breaking down what's given to us and what we need to find out. 9B says to write a rational equation using the last column of the table. Well, the last column of the table says this. To find the total price of the total price of the trail mix in general, we know that we're going to have 6.25 times 10 plus 4.5 times M. This right here, this is saying that the price of the dried fruit plus the price of the mixed nuts should give us the price of the total trail mix. Which means if I were to simplify this, I'm going to get 62.5 plus 4.5 m is equal to 50 plus 5m. All right, that's A and B. How do you feel about that, Isaac? Any questions on that? Anything you want to go over? All right, cool. And then solving that, Isaac, I have utmost faith in you to be able to solve that equation. So that's part C for that. All right, nice. Did you get m equals 20? You got it. M equals 25. And in this case, the question was how many pounds? So 25 pounds with the unit would be the answer. Okay, so number 10. So let's just look at that. That's a good question. So the first thing with number 10, just in general, is the fact that distance equals rate times time. This question kind of is focused on time. That's what we're really focusing on. If you look at A, B, and C, it entirely is focused on time. It says what is her time with the wind, what is her time against the wind, what is the time to complete the trip, it's time. So we want to isolate time. So I can rewrite this as distance divided by rate is equal to time. And we want to break this up into two different portions, one with wind, one against wind. Because if you think about the real life situation, right, Isaac, you're going to go slower when you're pushing against the wind. The wind's fighting you, you're going to go slower. When you're going with the wind, you're going to go faster. The wind's helping you, it's pushing you with it. So with the wind, we're going to have an advantage. The distance is always going to be the same. It's a round trip. All right, so let me show you. I'm just going to show you my face real quick. If it's a round trip, if I'm in a plane right here, and I'm flying this way, right, I'm going to be going, let's say, with the wind. So let's say this wind, they're going to go together. They're both going this way. That's me, that's the wind. And it's taking me with it, so we're flying that way. This is a round trip, so eventually I'm going to get here, and I'm going to turn back and go this way. So I'm going to go this way, and then I'm coming back. The wind is still going this way. So now on the way back, these are clashing. The wind's hitting me, I'm trying to fight it. So that's going to be like the actual situation. So to get to your destination with the wind is 20 miles. To get back is another 20 miles. So that's a distance. That gives us the distance. It's 20 miles because the total round trip is 40 miles. So with the wind, our distance, or our D is 20. Our rate. Well, we know that we're going to go, Alicia's average speed riding her bike is just 11.5. So when there's no resistance at all, no wind, no nothing, she's going 11.5 miles per hour. But since when we're with the wind, she's going to go 11.5 miles per hour plus whatever the wind gives her. And in this case, the wind, we don't know what the wind's giving her. We don't know the mile per hour of the wind, so we call that x. So 20 divided by 11.5 plus x. Against the wind, she's still going 20 miles. She still goes without wind at 11.5, but now we're subtracting the amount because she's going against the wind. So her rate is going to be smaller than 11.5 because the wind's going to, fight her. It's going to make her work harder. She's not going to go as fast. And that's the difference between the winds. One with the wind is going to make her go faster. When she's fighting against the wind, it's going to make her go slower. Her rate is going to be faster and slower for either one. How does that feel for you, Isaac? when it asks how long will it take, am I just adding up the 2 times that we are given? So yeah, when it's asking you how long does the trip actually take, yeah, you're basically just saying, if it takes you 1 hour and 20 minutes with the wind, 2 hours and 30 minutes against the wind, you just add them up. So 3 hours and 50 minutes. I don't even know why they asked that question. It's so stupid, but yeah, that's all it is. D is when you actually kind of use some rational expressions. I'm going to add this to my paper just so you know. X is equal to the speed of the wind. I do a bad job of when I'm explaining stuff over stream. I don't include details enough. It's on my, you should always label your variables. So even like this past 30 minutes when we've been going over this, I haven't labeled my variables very well. Make sure you're always doing that. Where would I start with the rational expressions? Okay, so rational expressions, basically at the end of the day it says write and solve rational expression to determine the speed of the wind. So we're writing a rational expression to find x, because x is the speed of the wind. So we're going to take with the wind, so that's the first leg of her journey with the wind, plus the leg of the journey against the wind, has to be equal to the total journey. Okay, so her total journey is going to be 40 miles. Oh, wait, no, actually, I think it says. Takes her an hour and 20. Okay, so we might have to be a little bit more clever with this. So that's going to be equal to, because this is going to give you the with the wind. That's going to be against the wind. So what we want to figure out then is how many in total. What's going to be your total? So we would take our total distance, which is 40 miles, is equal to the rate times the time, which is 3 hours and 50 minutes. Oops. 3 hours and 50 minutes in terms of time would be 3 5/6. So 40 divided by 3 5/6. What's that? Oh, okay. This is going to be 23 over 6. So that's going to be rational expression. So this part actually is just your, you didn't even need this equation. This is just the time. So this is going to be your time of with the wind. This is your time against the wind. That's going to be the total time. So 23 over 6 is just 3 hours and 50 minutes in fraction form. And I probably should be more specific with those. Time with the wind is there, time against, and the total time they give you is 3 hours and 50 minutes. Well, we found was 3 hours and 50 minutes. So that's where you'd start, Isaac, and then from here you would find a common denominator and work from there. Yeah, exactly. So if you want, you can take the next couple of minutes, try to solve that, and I'll let you know if you get the answer correctly. And you're solving for x, because x is the rate of change of the wind. 3.5. Okay, so Isaac, let me ask you, what's your answer? What would be the speed of the wind? Probably 3.5. Yep, you got it. That's the answer, Isaac. Yeah, the wind. No, there's no such thing as negative speed. So velocity can be negative, speed doesn't. Speed's the absolute value of velocity. So it's always positive. So 3.5 is your answer. Yeah, no problem, Isaac. Like I said, after this stream, I'm gonna try to get you that code. So keep an eye out for your email to join the Google Classroom. Yeah, you too, Isaac. Appreciate it.